Yes. Let me know if my screen is visible.
Um, yeah, I can see it.
Yeah. Okay. So we will be taking up this particular project, which is face blur for street interview. So hypothetical case study is what I've taken. Try to make it a little fun as well. And then yeah, we'll be digging through it, through the whole structure step by step, and discussing, brainstorming the problem, and then actually doing the activities like the programming activities. I'm not sure if we should actually do that, or maybe I'll just walk you through, and you can access the deep note notebooks and try it out yourself. But we'll see, we'll see. So this is the first time we are doing it. All right. Okay, I think we can start now. I'm not sure how many people would join today. So, guys, welcome to the Robotics and Artificial Intelligence meetup number 67. So, it's been a while since we did one of these meetups, because we were trying to change the format, and the format now would be more project based, and we'll see how that works. So, the first project that we would be discussing is that of computer vision, and we'll be discussing how to detect faces and how to blur faces. So for a particular, it would be for a particular case study for street interview. I'll tell in more detail what I mean by that. So the category of this project is face detection, object class detection, and also image filters. And we'll be using Python, OpenCV, MediaPipe library, and Git along the way. At each step, we would basically be making a commit on Git, so that you can make your own repositories as well alongside this. This is a very beginner friendly project, and I have actually taken reference from some of the existing projects and combined them, so it is not entirely original. But I think for starting, it does make sense so that I can familiarize you guys with the new format. uh, the hardware and software requirements, basically I'm on Linux right now, but you could do the same on Windows or any other operating system, and I'd just be using Vim, but I would recommend that you use Visual Studio Code. I'm more comfortable with Vim now, so I'll be using that. Okay, let's talk about the problem. So the case study is, it goes like this. So you have been hired as a computer vision engineer by the staff of a popular TV show that does street interviews with random strangers. Normally, the interviewees would sign a legal release giving consent to being recorded, but a few guests did not want their faces to be revealed in public. So, your task is basically to anonymize their faces by blurring them. The problem statement is simply locate and blur human faces in a given video, and we are basically given a video clip of the interviewees. So the initial and the goal states look like this. So you can see these are clips from the video, and these three people, there are multiple people in the video who are being interviewed, and their faces are to be blurred. So these are the goal states. So initial state is a video like this. Excuse the ads, please. Um, yeah, now there are two ads. Yeah, so basically, I'm muting the audio. Basically, the video is what we care about. So you see here, there are multiple people uh, getting interviewed here, and the task is basically that we would want their faces to be blurred, but we also at the same time don't want the face of the host to be blurred. So we want to keep his face as it is, but we just want to blur the faces of the interviewees, the people who are getting interviewed. And the requirements are that the faces should be detected and blurred consistently throughout the video. So the face blur, the blur should actually be maintained throughout the video, and all frontal faces except that of the host should be blurred, and the faces of the people in the background need not be blurred. They would not really be identified even because they're not front facing frontal facing faces basically. So that should not be a problem. Faces of all races, skin colors, and backgrounds should be detected and blurred, and faces at slight angles should also be detected and blurred. Basically, we are using media pipe library, so all of these requirements would be taken care of uh, in this implementation. The assumptions are that the lighting conditions are uniform throughout the video, since it is in one particular setting and faces are mostly frontal, as we've seen in the video. So the goal state would look something like this. So you see here the faces are blurred consistently, and the face of the host is not. Basically, this is what we want. So before actually presenting the solution, the format that we'll be following is, and also feel free to like give your feedback on the format. The format would be such that we would first do a little brainstorming of the possible solutions. Of course, the solutions and activities are there available, but there are of course multiple ways of solving a problem, and so it makes sense that we do a little brainstorming and collect some ideas so that you can actually think about the problem first, and then we discuss about one of the solutions basically. So has anyone worked with face detection, face blur, or something similar before? None of you guys have, or
I have used scikit image library.
you have
Um,
used scikit image library?
yeah, with
Okay. And what exactly did you do?
just like introductory computer vision exercises, like
Okay, scikit
mask.
image library, right?
Yeah, yeah.
Okay. And what was this based on? Was it what was the algorithm and all that you used? Do you have any idea if you remember?
Um, I forgot the name, but um, yeah, I guess it is very similar to the CV library.
Hmm. So,
So
like basically, there are a few algorithms. We'll not go into the theory of the algorithms. Maybe we'll do another session where I can prepare about the hog transform way of detecting faces and other algorithm, the deep learning based system, and so on. But basically, here we can just collect ideas. So, in scikit image, I don't know what way they use to do face detection, but it could either be hawk based or deep learning based or nearest neighbor based way of face detection. So, say scikit image face detection using a cascade classifier. So, yeah, I mean, we don't need to dig deeper. Like we are just collecting ideas. So yeah, this is we could use this library basically to do it, and it is basically using her cascades. Uh, yeah, this is a very popular way of doing it, and uh, yeah. So you use this library basically for face detection. And did you also do you have any idea of once a face is identified and detected, how is it? How we can we blur that or pixelate it? Not really. So you basically worked with face detection, huh? Andres is saying something.
Yeah. Uh, Hi. So yeah, I was also thinking about the hard cascade approach. That's quite reliable. And for the blurring, just let's convolve a small filter, right?
Yeah, exactly, exactly. I mean, You taught us these things, so you know.
I'll better stay on the sideline.
Yeah, sure. So yeah, like the filter, Gaussian filter, or other filter-based approaches, basically. So like Andres, like this is a new format that we are trying. So like, feel free to give your feedback. We are using these deep note notebooks. I think I also shared it with you that I'm following this approach now.
Yeah, yeah. I'll just be here watching around for a while.
Yeah, thank you. Yeah, so face detection. And Abhinav, do you have any idea about face detection, face blur, or have you worked on it?
No, I'm actually a beginner to computer vision. I've just started learning through YouTube.
Okay, 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 nice. Yeah, so basically we could just like collect some ideas and um, yeah, so we can say that like the face blur problem is a combination of, let's say, face detection and blurring, and there are multiple ways that we can do face detection. So one, as was mentioned, is like Haar cascade, which is a popular way of doing it. So Haar cascade approach, or deep learning based approach. um, Yeah, I think these are most popular ones. There are a few more approaches as well. So maybe let me. So so this is one good resource that you can refer for generally like computer vision stuff. So this was one project that they have also done, blur and anonymize faces. I'm using a different library. They have done it with just, I think, Python and all. But what I want to check is, yeah, the approaches. So here there's a good introduction to different ways of face detector. So one I also mentioned, Hog plus Hog transform based and linear SVM based, and another is Haar cascade based and deep learning based. So yeah, the Hog transform based, Hog plus linear SVM based. And yeah, maybe at some point, I don't know if it makes sense to discuss these in more detail in one of the meetups. Right now, I think we can just collect ideas, and so this is face detection, and then blurring. So for blurring, Gaussian blurring, I think this is the simplest way we can go about it. And so now that we have an idea of what to use, like would someone of you like to talk about like the overall pipeline of how we can start approaching this project? Basically we know the problem now. Now how would you be approaching it? How would you start with it? Like we also know that there's other libraries, scikit image, actually, like dlib, and there's like OpenCV based deep learning. There's also deep learning implementation inside OpenCV itself. So there's like multiple libraries that we can use, and of course like MediaPipe, which we are using here today. So yeah, does anyone want to mention like some of the pipelines that can be used, or just any other idea in general? Okay. Yeah. So basically, a broad way of dealing with this problem is, of course, we would do face detection first using one of the libraries, and then we would extract a region of interest, which would be the facial region, and then we would apply blurring onto that, and then we would store the blurred face onto the frames where our faces are getting detected. So this would be the broad view, and this would be like the overall algorithm. And in this also, like, of course, now the question would be which face detection approach to use, uh, which libraries to use, and so on. And this would basically depend on the requirement. So I'm using MediaPipe because for this particular case I want a real-time phase detection, which real-time and accurate phase detection, and MediaPipe is shown to perform better compared to other results. Although scikit image I have not really tried, so this is also something that can be considered. Um, and yeah, so once we get an overview of the algorithm, now we would start implementing it. So so each project, the structure that we would be following is that, wait a minute, why is this? Huh.
I have a question.
Yeah, yeah.
So what does this media pipe uh, actually do? Like it like extract each frame and then you can.
It's just a library like OpenCV and all.
Oh,
It's
okay.
wait. Yeah, so it offers like cross-platform ML solutions. So it can be used on Android, iOS. It can be integrated on the solutions can be integrated on Android, iOS, and other platforms. And
Oh,
it is basically it gives like really good performance. It is by Google, I think, as well. So yeah, this is being used a lot these days. And so yeah, I'm just using MediaPipe in this case. But of course, like the idea of these like meetups or these project discussions is that you could try out other libraries also, and maybe you find like better results even in some cases. Although like for this particular case, as we see, like the detections are pretty this is the input video, but in the output video we saw like the detections were pretty consistent and accurate as well. So I think that was a good sign. So yeah, so it's a good question. Like you asked MediaPipe because I was also not aware of MediaPipe a while back as well. So the idea is like in this system, we would basically break a project into activities. So the first activity would be actually to find out which library you want to use, and perform installation and importing of all the dependencies and libraries that are needed for the project. And then of course in this project, as we see, we have one input video and one output video. So we need to handle the input data, understand the input data, and then perform face detection, and then perform face blur, and then save the results. Now the problem that we generally come across is that we don't know a step-by-step system. So this is what I'm trying to do here. So importing the libraries and then understanding the input data. Okay, here I think this thing is also copied as an image somehow. I'll delete it later. So yeah, so install and import project dependencies, then understand input data, face detection, face blur, and results. So as you can see, each of these have sub activities. Each of these activities have sub activities, and all of these activities also come with concepts, like theoretical concepts that you would need to know. Um, so for example, like one step would be of course to figure out which library you want to use, and then actually like do a little study, just get an overview of like what libraries are available, which one to use, and so on. So as we are using MediaPipe, so MediaPipe and OpenCV, so what is OpenCV, what is MediaPipe, we'll talk about what is time library and OS library. We just need to get a little introduction on it, and then we could just install it, import it, and then store the input video, download it, and just store it, and then uh, read read the video, display the video. And for that we need to understand what frame rates are. So I'm trying to make it as beginner friendly as possible, so anyone can actually start using it at any stage. uh, And face detection basically is yeah, so we would initialize a face detection module, so media pipe in this case, drawing utilities, and then pre-processing the image. So the images need to be in grayscale for face detection, and then perform face detections, and then visualize detections. And even these sub activities, in some case, I've divided into sub activities. Not sure if this helps, but yeah, I'm open to any feedback also. And after a face is detected, then we blur the faces, we determine the size of the blurring kernel, apply Gaussian blur, display Gaussian blurs, and blur the faces. So again here, uh, the concepts. So you only learn the concepts that you would use, and not you don't need to watch like an entire lecture of how face detection works and all. You need to understand like which algorithm you be using. For example, if it is a Haar cascade based approach, then the concepts that you would be learning are how does that work, and how would you implement it, essentially. And then after that, just perform face blur and save results. So now coming to the main part, so there's also like a system setup. So the way I think we should be using these deep note notebooks is not like Jupyter notebooks, in the sense that you could just start using it and playing with it. You could do that as well, but what would be, in my view, most beneficial to you and everyone would be like if you start a GitHub repository and actually implement these solutions. So let me tell you what I mean. So I'm just using Vim. If it is not very clear, just feel free to ask. So projects, I'll make a folder like live projects, so on. And so let's make a GitHub repository. Face blur for street interview live. So this is a GitHub repository, and I think how many of you are familiar with Git? I think most of you probably, right? Abhinav, are you familiar?
Yes, I had attended the talk that we had.
Okay, nice.
So
Yeah, so basically we just need to know a few commands. So we'd clone this repository here, unpacking objects. So face blur for this is an empty repository now, and now we would just like I've tried to gamify this thing. So we are given a task like in video games, like maybe there's one mission at the end that you want to like beat a main like monster or something, and then you have like smaller steps. Maybe you have to collect some things and like yeah, do some sort of tasks in between. So like this particular task is just installing OpenCV media pipe, time, and OS. So this is a pretty like straightforward task, but also the concepts, the resources are attached here as well. So OpenCV. So right now I've just like randomly linked the official pages and all, but maybe eventually I would link like short descriptions, like very quick, so you could just check it here as well. And so now this is the task. So it is pretty straightforward, and you would just Google search how to install OpenCV and all. Uh, and you would pip install OpenCV Python. You would just do that. Like for me, it's already installed, so I don't need to do that. So install all of these files, and the solutions would be hidden. How many of you have opened the notebooks right now?
I have.
Okay, you have. And what are you able to
yeah, I
see?
also.
You're also able to see it like this, like the code has been hidden or something, right? In this particular block, in the activity blocks.
Yeah, the code has been hidden.
Yeah, exactly. So these are like the solution blocks. Actually, if you just duplicate it, you would be able to also unlock it yourself. So that's not a problem. Initially, the idea is like the code would be hidden, and so the idea is if you have no idea, like you would check hints. Of course, this is a very small simple task. So hint is to install these packages using pip. So like someone who is like absolutely a beginner, maybe he would search how to install using pip and so on. And if even that doesn't work, then you would check out the solution that how would you install it, right? So this is the idea. And after that you would import OpenCV again, check the hint. So here, using this notebook, basically you would probably get an error, and then you would have to install something here, and that would fix it. So just update it and install this libgl, and just import these. So once these tasks are done, then you would store input video, and here also the tasks are clearly defined that you would create a new folder named input video inside the main folder, and output video inside the main folder. So yeah, so for me this task is already done, it's installed, so I'll just import it. I'll do activity 1.2 now. So vim main.py. So just import cv2, import media pipe as mp, import time, and import os here, right? So this is one particular activity that is done, and then you to actually have it in a structured way on git, you could basically just be committing every single activity that you do. So this is like the repository that I also uploaded there, that I shared in the announcements. So you see here, the commits I have named it in terms of the activities. So activity A 1.2, import OpenCV media pipe time OS, right? So and then store input video. So this way, like you document the whole like project in a step by step way, and you actually do the project, because generally like following the tutorials is also it helps, but it doesn't help totally, in the sense that you are not thinking. Like if you break it into projects, and like if you do each activity, and if you make your own commits alongside, and if you push it on git, then I think like you'd actually be building a project, and you can showcase it to a potential employer or something. So this is a 1.2, import OpenCV media pipe time and OS, right? And then I'll just push it. Oh, I have to copy this again now. So while I'm like copying my token, like does it make sense? Like, and what do you think about this particular format? Does it help and so on? Yeah. Andres, what do you think? I mean, I think your feedback would be also very helpful.
So far, so good. Maybe quick question. Does everybody know what's an image that we're dealing with? Or, I mean, even from simple concepts, it's nice to introduce them,
Uh,
as well as maybe the overall objective.
what do you mean? Like the about the task, or
Maybe in the task, does everybody like it's good to clarify? Does everybody know that an image it's just a two-dimensional matrix full of numbers?
Ah, yeah, okay, okay, okay. Yeah, you're right.
Like adding conceptual requirements to the notebook, maybe?
No, like Andres wants to ask, like, do you know how an image is represented? Like, uh,
Oh,
because like this is like the fundamental image. Like what a like the meme thing, right? The what a computer sees and what you see. Like, so like we have these things like this is like divided into the computer sees basically a set of numbers like the intensities of these values. Or like there's this meme that I'm trying to search. But you get the idea, right? Like this image is like, for example, a portion that is of a pixel. Like, so each of these, the entire image is divided into several pixels depending on the resolution, and so each pixel basically we have a number, and that number represents the intensity of that intensity value at that pixel. So a value of 255 means that a white color is there, and a value of 0 means a black color is there, right? uh, you guys know about that, right? Andres, this is
yeah.
what you wanted to convey, right? If I understood
Yes,
correctly.
yes. Just it's nice to always introduce the basic concept at the beginning, even if it's a little bit redundant. Same for
uh,
like what's GitHub that maybe you commented a couple of times. I don't know if everyone also knows.
yeah, yeah, you're right. So like GitHub is also like just to briefly mention, it's like a version control thing. So as you can see in this particular repository, yeah, in this particular repository, so these are like commits, which is like a collection of history of all the changes that you make. So at any point the main idea is why we are doing it this way is, so if you want to, if you made a mistake after let's say drawing detections manually, if you made a mistake there, so you can go back to any of the previous steps and you can proceed with that. So it's like it's like having a history of all the changes that you make, and like undo and redo changes basically, if that makes any sense. um, yeah, for more detail I guess like you could check some short video, and I think like as we use it also it will make it will be very clear. So I think Juan already also knows about Git, and like Abhinav, you have no idea about GitHub, right?
I have a basic idea, uh, but I've not started properly using it yet.
Okay, okay. I mean, as we do commits, that would also be clear. And I am Stark. Do you are you familiar with Git? So maybe yeah, I'll also like as I type, I'll also try to explain a bit. So Git status is basically it would be a bit hard to explain this also. Like Git status is basically where our current location is, current status of this thing. So and I'll check now Git log, which shows our history. So as you can see, I uploaded I committed this particular change, import OpenCV media pipe time and OS. So let's look at how this looks in our repository. So this is what we created initially, and if I refresh it now, so you see there's a main.py with all the import commands there, and in commits you are able to see this. So this is the commit that we made. So I typed git add dot, so that it adds all the changes and then it commits all the changes that we make. So this way we are building this particular history or a collection of the changes. Okay, so now we are done with activity 1.1 and 1.2. Now the idea is that we want to store input video, we create a folder named input video, and we create a folder named output video. So I'll just mkdir input video, kdir output video, and then I'll just I'll just copy my input video. Basically, I think I'll just copy it from here. Trial.mp.
We conducted an experiment. People eating.
Yeah, so I'll just copy it. I mean, since it is just one video, so I'll just copy it in the repository. Generally, actually, the data we should also avoid keeping it in the repository because it increases the size. But for now, I think it should be fine. It's 39 MB. But generally, we should avoid keeping the input data also here. So you see here we have this. I'll rename it to input.mp4. All right. So we have this input data, and let's see, have we done this activity? So create a folder named this and store input. So this is activity we did already, and then store input data. So I'll just commit both of these changes together. So git status, git add. Git add is what we do first, so that it adds all the changes that we made to an intermediate step before it is committed, and git commit actually then pushes it. Git commit actually then updates it, and then after that we push it, and then it is highlighted in the remote repository. So git commit would make it update it locally. Git commit -m, and yeah, store input video and activity 1.2, activity 1.3. Yeah, so 1.3.1 is create this thing, and 1.3.2. So yeah, it is activity 1.3. It's correct. 1.3, right? Git push. Now as we push it, yeah, now here store input video, and we see that input.mp4 is here. So this step is done, and also yeah, how to download videos from any site using it. So I have added this as a hint here. Wait, why am I not able to click this? I signed out somehow. Okay, yeah. So yes, now that we have stored the input, now we can go on to activity 2. Activity 1 is done. Now activity 2 is load video. And so how would you load videos? You would search how to capture video using OpenCV. This is a hint, and if even after hint you struggle for a while, you can just then directly see the solution. So for now I'm just copying it directly. So I'll go to my main.py, and then yeah, and then I just import it, and let's try and run and see if it works. Input video, okay, so I named it as input video actually, not input videos. Wait, can't find starting number name of input video input mp4. It's also capital I. Okay, sorry. It's capital. I think this is fine. cd input video input.mp4. Sorry, it's problem is also with the file name. So mp4, yes, and now we run it and it's fine, so we have no error. So we now loaded the video, and now the idea is we want to read the video frame by frame. So for that also there's a hint is like pretty, the hint is maybe not that helpful. Read video using OpenCV, but I think if you the hint is supposed to help you search using the right terms, and if you're not able to figure that out also, then you go to the solution, not directly. And so yeah, so this is basically a way to read the image once it has been defined using OpenCV. So we do that, and it's a good idea to always run it and see if we are not having any errors. And a 1.1 2.1 and 2.2, so we have read the video, and now we want to display the video to see if what we are reading is actually correct or not. So it's taking a while to read because it's a 4-minute video, but there would not be any error. Now let's just display, and then I'll commit all of these things together in as one commit, vim main.py, and then we display the video. So again, you check the hint. How do we display video or image in OpenCV? It's just imshow. So we'll just use cv2.imshow, and this is pretty straightforward, right? And then after that, and we also have to define a wait time so that it actually displays. Otherwise, as you saw, it didn't display it. So now we are able to see that the images, the video, what we are seeing is like the each frame of the video is being displayed one after another. So frame by frame we are displaying the video. So imshow, so after image is being captured, each after the video is being captured, image by image, frame by frame, we are displaying it one frame at a time. So now we have done this display video, and then we as you saw, like the video that we had, it is a bit faster, right? So you see that this is not real time, so it is not the frame rate that is actually there in the video as well. So the way that we change frame rate is here, simply for displaying purposes, we just like change the waiting time. So if we increase the waiting time now, so you see now here it is slower. So that's how we can change the frame rate by displaying, but we'll keep it just one. So change frame rate. So as you can see here, so this particular task is, so here this is the one with frame rate, and yeah, just wait key. And then also we want to have the ability to actually close the video, because generally now what I'm doing is I'm going back to the terminal and then pressing Control and C, which is the shortcut, but we also want to be able to close the window on pressing a key. So okay, so here the task description I have not written correctly, so I'll update it. Write a condition to close the window on pressing a key, right? So break the loop when Q button is pressed. So the hint is like how do we exit it? The loop should be broken, and that is done on pressing a key. So we just add this particular condition if cv2.wait key 1, and this is like if the key pressed is equal to q, is how we define it. The idea is, of course, here I am just copying directly from the solution, but the main idea is that you would try to figure it out yourself, like write a condition to close the window on pressing a Q. So you would probably check the hint, you would see how this is done, you would google it and all, and you would try to do it yourself, and only if you are not able to do it, then you can check the solution. So this way now we are done with activity 2, which was just basically displaying it, and we can also check this if this is working now. So this is the video, and if I press Q now, you see that it closed. So now we'll just push it, get status, get add, get commit. So commit would be, I mean, we did a couple of activities together, right? So A2.3, A2. Yeah, these are all A2.3, A2.1, 2.2, and 2.3. I think we can do it that way. Let me check the last commit. A1.3. So A2.1, A2.2, and A2.3. Okay, so committed, one file changed, 8 insertions, git push. Okay, and now we see here that these are also committed. I forgot to write like the change name, but I think it's fine. So yeah, I want to pause before we do start with actual face detection. Does it make any sense, or maybe it's also not very efficient? Do you want to try it out on your own at a later stage, because like everything is there and now you probably have an idea, or should we finish it now? What do you guys say?
Either if we finish it now or not, I will definitely try it out later. So
Okay.
either way, it's fine for me.
Okay.
Maybe for the next iteration, it would be amazing if there was one small session to introduce the problem and then later a second one to review the solution. That would be nice.
Okay. So maybe yeah, we didn't talk too much about the problem, right? Yeah. So this is like, yeah, this is good, because this is something I was not sure how much time we should spend on this. So this is what you mean, right? So like talking about the problem and like brainstorming solutions before, or just the problem?
I don't know, like the first part of talking about the problem and brainstorming solution as we did was nice. It's just that many people may want to have some time to solve it on their own.
Okay. So it was too quick. Yeah. Okay. Okay, got it. Yeah, from next time we will try to do it that way. Yeah, and activity 3. Yeah, maybe I can just like now. I don't need to do it all, but I can like explain. I can just show the code and do a little bit of commits here and there and show you. So maybe let me open the final projects. Provision, face blur. Yeah, there we go. So yeah, I'll just open the code now, and we'll see the activities and also the code and the GitHub repository I'll open alongside. So we did display the video as you saw. And now the task is to perform face detection, and for this you would need to know some concepts like how face detection works using MediaPipe. Honestly, I have not updated these concepts because I think that would take more time. But to give you an idea, generally, like if it is a hog based approach, or if it is a har cascade based approach, a little bit of theory or maybe an existing video would be linked, or maybe I'll write a short description, but an introduction to the concept would be given, and then we would do the activity, because otherwise also you have no idea, right, what har cascade is and all. So initialize face detection module is this particular activity now. and implement here. So normally if you have access to this, and if you duplicate it now, actually let's try this out. Like, so all of you guys can just see the code has been hidden, right? So maybe what you can do now is you can go to this button with three dots and just click on duplicate project, and then you would be able to see it like I'm seeing it. So this show it button would also be there, and then you could actually directly see the solutions yourself. Otherwise the solutions would not be visible. Yeah, so let me know when you're done and when it is visible.
Okay, now I can see the solution.
You can see the solution now, right? Yeah. So I think this is how we can continue doing it. Like, I'll just share uh, these deep note notebooks with like this, with this approach. And so I think you can also not edit in the original one. Like, when the code has been hidden is there, you can still not type here, or can you type there? uh,
Let me
in
see.
the original version. Of course, in the duplicated one, you can do anything you want.
No, it's not possible.
It's not possible, right? Yeah. So I mean, in the duplicated one, you could just actually first try to do it. Implement here like in the original block, and only like only show it when in the worst case, basically. So yeah, I'll see if I can somehow just display the original blocks. Uh, Execute edit, because edit allows you to see everything, but I want like two versions. One is where only these are visible, and one where we have solutions. But yeah, I'll see what can be done about that. Okay, so initialize face detection module, right? And so we use media pipe face detection module, and like this thing you will be able to find using Google search. So media pipe face detection, right? So here there is an example you see here. This is the initialization. Import CV2, import media pipe as MP, and then after that this is the initialization. So MP face detection is equal to MP dot solutions dot face detection, and this is like the drawing utilities. So this is what we do here. So solutions dot face detection, and then we initialize this. We assign the face detection to a variable called face detection. So this is something we do, and then again initialize drawing utilities is where you will be able to see solutions dot drawing utilities. So this again, with a quick Google search, you will be able to see how this is being done. um, yeah, when using a library, of course, the thing is, the good thing is, and also the bad thing is that it's just a one line way of implementation. But what we should actually aim to do is actually have also understand what is the algorithm behind it, and maybe then even if you implement it using just one line of code, that's still fine. But to debug it, maybe I mean it does make sense to know the algorithm. So and then after that we do image processing for face detection. So this is convert image to RGB. You check the hint, you use CVT color to somehow convert it into RGB, and then we just do that like cv2.cvt color. So I'll not go into detail of this. I mean, you could easily check this later. So image is being read. If success, then we change the color, make it RGB. And sorry, I think initially I somehow accidentally said it is converted to grayscale or something. It's kept in RGB. Performing then is where our face detection is being performed. And so here again, this is pretty straightforward with this module, face detection dot process image RGB. So, and then we would visualize the detections. And have you print the detections, visualize the detections? Actually, I'll want to show this to you. And then after that we do face blurring, apply Gaussian apply Gaussian blur, and blur only the required faces, and save. Yeah. Let me just show you briefly, and then I think what we can do is, like, you can try out this thing on your own, and then after that we could do another session where we could actually do it together if you want. Yeah, I'm also open to any suggestions there. So this is like the final code here. So Python 3 face blur dot py. So you would be able to see the right input. So his face is not blurred. Here, and the guest, we see like his face is blurred, and all the rest of the faces, as we saw in the video, would also be blurred, right? So this is one thing. And if we now, I'll comment out the face blur thing, and just show you face detection. Face blur is not being done using media pipe, right? So for face blur we used Gaussian blur, and this is how it is done. But for face detection, we just use media pipe. So let me see. So yeah, okay, I can show you like the original. So originally, like, media pipe shows you a bounding box around the face, but also um, some landmarks. Basically, we don't want the landmarks. So here, like, this is how originally it would be, like the face being detected and the landmarks. So this is what uh, I did before, and then after that, yeah. So these are commented out, and then after that, I just print the rectangle manually using CV2, and I still take detections from our the media pipe outputs, basically. So location data, VBox C. Yeah, I think it's fine. Expand rate. VBox Xmin. Where have I defined Xmin? VBox C dot X Xmin. Okay. Xmin is here and VBox here is. Yeah, let me see. For now, I'll just copy it. Sorry, here. After VBox. No. Wait. So X-Men and B-Box actually. Let me see in. Vim face blur raw dot py, right? Bbox c dot x. It's correct, right? I mean, it takes it from this. So why was I getting an error? Computer vision. And yeah, sorry, I don't want to waste your time. Um, yeah, I mean, it is correct. It is taking from X-Men, right? And then after that we defined that is another X-Men. So CV2 dot rectangle image box. Yeah, is X-Men is equal to B box 0 in invalid syntax. Invalid syntax. B box. Ah, this is this the reason put no B box 0 invalid syntax. I think this could just be it. B box is not defined. Anyway, I'll check it. I think later because I don't want to waste your time. But basically, what I was showing you was like as you saw, like the media pipe library face detection module. It shows us also the landmarks. So we don't want the landmarks, and we just wanted to see the bounding box manually. So the idea is in face detection you would be able to visualize just the bounding boxes around the faces, and then inside the bounding box region you will be able to blur the faces. So we'll apply a Gaussian blur filter. Gaussian blur. Yeah. So Gaussian blur is generally used in image processing to to smoothen to smoothen the tasks, to smoothen our image. And basically this particular filter here is the math of it. So this is like an image, and here the image is basically like this particular small rectangle thing, and the rest of it is black. So intensity is 0 and so on. And then we take a Gaussian filter. This is how it is represented, a Gaussian filter, and then we pass it through the image, and the output is that it smoothens it. So I would recommend that you check out a bit of theory online, and like this pretty simple. And we could discuss like the theory in one of the other sessions maybe. um, but once we apply the filter and pass on in a sliding window fashion to the image, then it blurs the image. And this is the concept behind it. And then after that we just save the results, and we use video writer codec to do that. And we define the video writer module. We define where our output should be placed. We define the initialization here, and we define the frame rate. So this is 30 was the frame rate in the actual video. And here, you can check the frame rate of the original video, for example, in its properties. Frame rate, so 30 frames per second, so we have to keep the frame rate same here. And yeah, also this thing is in the concept. This would be like how this thing is structured, its format. This would be in one of the theoretical concepts, like define video writer object, syntax of video writer object definition, and so on. So like what are each of the terms, you would be able to read it or watch it in the concept video, and then you just display the output, and you see the blurred images. And after the project, basically you can check alternative solutions, alternative ways of solving the same problem. And this can also come from the brainstorming session and like similar projects, other face blur or face detection projects, and so on. And then I've also, as I mentioned, the project is like I didn't build it from scratch. I just used snippets from different resources. So one is, of course, I checked PyImage search. Actually, I just used the blurring module from here, and yeah, a few other videos and face detection things from here and there, and so on. And if there are also some issues in the repository or in the deep node notebook, you could just write it here and also give any feedback uh, basically here. Once you have the access, I think in the original notebook you could also comment anywhere. So I think that would be fine. And if you're stuck in one of the activities, or if you don't understand something, you can just write it in the comments. And so I would also be able to see it. And for your own access to the solutions and other things, you can duplicate it and use it. Yeah, I think that is it. So I'm also curious to know your views on this format, and how helpful this it is, and any other suggestions to improvement. So like Andres also mentioned about discussing more about the problem, so we'll definitely do that from next time. Apart from that, maybe let's have a short round, like what do you guys think? You can be like honest in this, because this is a new format we are trying now. So let's start with Abhinav.
Yeah, I think even as a beginner, I found this doable. So I'll be trying it today or tomorrow.
Okay. So I know it's also a lot of new things for you. So maybe you could spend some time understanding the problem and what are different approaches. Maybe like do some uh, searching online, do some research online, and then try to do it. And if you also have any trouble, yeah, this is also something I can mention. Now this whole so we have a team of project volunteers also. So if you have any trouble with the projects, you could just start writing it in general help or Python help. And if you can write that, hey, this is the project that I'm doing and I have problems, then I mean, some of us would probably be able to help you there. So this is another thing. um, yeah. So yeah, Andres, in general, uh, do you have any other suggestions?
Uh, from my side, I think the format is nice. I like it. Uh, maybe there's one small thing. Uh, of course, at the beginning, it's nice that you explain a little bit like what's the problem as you did, but then like which are like the most basic concepts that people may want to know. Not all of them,
Huh.
like a couple of them, so that people understand more or less what they will learn with the specific tutorial.
Ah, okay, got it.
It's like, to solve this tutorial, you may want to, like, you'll have to learn about these 3 points at least.
Okay, yeah, yeah, yeah. I think that is that definitely makes sense. Um, So initially, what I had was also like a list of concepts that you would learn, but then I just kept it inside this. But I think it makes sense. Like, what are the concepts that you would learn in this video? And yeah, I'll definitely include this. Yeah, thanks, Andres. One, I know you've given already
Um,
a lot of feedback.
yeah, I guess the the structure is nice. I guess the Andres idea is also good, like adding the basic concepts to maybe the requirement and maybe explain a little bit at the beginning for the people who don't really know.
Okay.
And I guess the rest it's fine for me. I mean, I will have to try it out and tell you more feedback if I have more. But yeah, so far, good. Yeah.
Yeah, you could even just write the feedback in the comments. I think you have access to the comments in the original one, and so I can like have these all together and update the format basically.
Okay. Yeah.
Yeah. So yeah, I think today overall was just an overview. I would say like not deep at all, just like a very uh, quick introduction to the problem and. Yeah, another thing I wanted to ask was like um, the thing that we discussed like few weeks ago about the accountability thing. So, do you guys prefer to do these projects on your own individually, or do you guys want to make like groups and do it in like as a group of 2 or 3 people together and then share progress, or what do you guys think?
I feel for the meetups, a group session could be nice, but you know, when I am trying to do a project, I, uh, I mean, I think my preference are like doing it by myself.
Okay. Yeah, that makes sense. Uh, yeah, no, like what I mean by this accountability thing is like, of course, you would be doing it individually. But for example, like maybe Abhinav is also doing it, and so you guys do it individually, but then you like keep each other accountable if you get stuck or somewhere that hey, I'm at this in this activity of the project and so on. You know what I mean?
Yeah, I know. Yeah, that could be interesting. Yeah.
Yeah, but yeah, I guess like for now, let's keep it simple. Okay. Yeah. So these are some points, and I had another thing I wanted to ask, which is like, so this face thing is like a random. I randomly chose this topic, and maybe I'll do more face detection projects since I'm already now in this topic. But what kind of projects would you want to do? Is it like more computer vision specific, or even in computer vision, there's a lot of different things, or ROS based robotics? Like, what should we be focusing on? What interests you mainly?
Mm, I think it will be nice to do a poll, maybe, so we can
Yeah, you're right. Yeah, because
let the democracy say.
hmm. Yeah, that makes sense. Sure. Okay. Yeah. Thanks a lot for joining, guys. So I'll stop the recording.